week, we are just focusing on unit 3. So that was something we should have done per semester, but there was just not enough time. And we needed to make sure we taught you all the hard stuff first. Or the stuff that would be harder to learn later on. Because you will see all of this stuff again, just a little bit harder each year. So it would help to see some of the unit 3 stuff now. So you should have picked up 3 papers. They were not necessarily going to do every single part of all of them. We're just hitting the highlights. Unit 3 was already a short unit, and then we're only hitting the highlights of it. To prepare you for the unit 3 quiz, so let me go to the to prepare you for the quiz that is on Friday. That quiz would have ordinarily been your unit 3 test, but I won't make it 100 points like normal. I'll just make it 50 points. And I'll call it a quiz instead so that you can use your notes on it. All right, so I'm not necessarily doing the binder check for this unit because it's only been a few days, but it's all on you if you want to take the notes, so then you can use them on the Friday. If you don't, well then I guess you don't get that resource. So it's really all on you for this last unit that we are going over. I've talked about all of this before, so if you've been needing to retake anything, your choices are either this Saturday at Saturday Academy or next week on Tuesday. So I would say the sooner the better, in case things come up. I mean, I'm still not having to do anything. You have to make arrangements if you want to retake some. Questions on that or anything I said? All right, so then let's start with the analyzing lines of fit. So yesterday we learned how to estimate them. Now we're going to see if it's a good fit or not. So really, I'm mostly teaching you good fit. All right, and one part of that quiz is residual. So a residual, that's our first link here, is the difference. What does difference mean in math? Subtraction, so it's a subtraction problem. It's the difference between the observed or your actual y value, so that would be the dots on the scatter plot, and the predicted y value, which would be plugging into your line of fit. Okay, so observed would be like if you actually did the experiment or collected the data, that raw data. And then predicted is from the trend line. It is also the distance from the actual plotted points, so like the actual dot, to the area on the regression line, so to the line itself. So here's a visual, predicted versus actual. All right. So if you have it on the line, so maybe say this is a scatter plot point, would you expect that residual to be large or small? Okay, Brian says large, anyone think small? All right, if it's the distance from the actual plotted point to where it hits on the regression line, then if it's on the regression line, that data point, then we should actually expect it to be 0 or close to 0. So the farther the way it is, would you expect the residual to be larger or smaller? No, larger. So here, let me give you an example. So say that these are some of our actual values. So say that I have one here and that I have one over here. Which residual would be greater, this one or that one? Do you think this residual is greater? Smaller. Because residuals are the distance from the actual point to the line. So if it's on the line itself, then the residual is smaller. Does that make sense now? So then what about in comparison to this one? And let's do that dot right there. Which one has a greater residual? The one on the left or the right? The one on the right, because it's farther from the line. Does that make sense? Okay, so that's how you can tell it visually. So then looking at the distribution of residuals can help you determine how well a line of fit describes the data. So residuals that are closer to 0 indicate a better line of fit. So that means that your predictions are close to or exactly the actual data point. That makes sense? So we'll see. So here's the first example. Use residuals to calculate the quality of fit for the line y equals 0.25x plus 29, where y is the median age and x is here since 1970. So this one, they already gave you the line of fit. All right, you don't have to estimate it. They gave it to you. They're asking you to figure out if it's a good representation of the data. So here's one way to organize your work. So here's like my raw data. And they did say that X is year since 1970. So my X's are actually 0, 10, 20, 30, 40. So would this be my actual data or my predicted data? This is all right here, my actual data. So what this person actually got from conducting a survey. All right, plugging into the trend line would be my predicted data. So that's what we're filling out here in a way to organize our information. So here's my input. Here's my actual data that I observed. Now we're going to find what the predicted is based on the trend line. So how are we going to find them? Would we plug in this X or this Y? Okay, why do you think Y? We are trying to find the Y value. So in that case, the Y should still be unknown. So what are we plugging in then? The X. So if this is my X, I'm going to compare it to my actual by plugging it into my line of fit. And that will give me my predicted Y value. So what's 0.25 times 0? 0, and then plus 29 is 20. Okay, good. So that's my predicted Y value. This is how I get it. Plugging it into the chart. Questions on that? All right, and then for residual, we said it's the difference between your actual and your predicted value. So it's just a subtraction problem. What was my actual value? 29.2 minus my predicted value, which is what? And my residual then is 0.2. Now, would you say that that's pretty close to 0? Yeah. So is this so far a good representation of the data or a bad one? So far, so good. So for the residual, to remember that formula, I mean, you get to use your notes on Friday, so you don't have to like remember it right now. But I just remember it, it's in alphabetical order. It's always the actual minus the predicted first. So A minus B. All right, we don't need to fill out every single row on this table because I can tell you right now, this time you're not asked to calculate the residuals, but I have seen my students be asked that in the past. So just to make sure we understand the residual part, I'm only going to have you try next row. So when X is 10 and when X is 20, calculate your residual. All right, but table 2, what'd you get for your predicted Y value when X is 10? Okay, that is what I also got. So good. It's a simple plugging in and calculating it. You just have to know what to plug into. So we're plugging in the input, which was 10, into our line of best fit. So according to the line of best fit, I should expect my data to be on 31.5. Where is it actually? Table 3, where's my data actually at? For row 10.
31.3.
So then when I'm calculating my residual, I should be subtracting 31.3 minus 31.5. So then table 3 with my residual. Negative 0.2. Is my residual allowed to be negative? Yeah, if the actual happens to be smaller than the predicted, then it will be negative. As long as it's pretty close to 0, then it's a good measure for your line of fit. Does that make sense? Okay. Table 4, what'd you get for the predicted y value when x is 20? So I should only hear table 4. 34 even. All right, that's what I also got too. So then my residual table 5 is what? 0. 34 minus 34. Actual minus predicted gives me my residual 0. So based on just these 3 residuals, would you say that that trend line is a good measure of the line of fit?
Yes.
Okay, great. So, you know, because it's pretty close to 0. How else you can tell is by what we call a residual plot, which is on the next page. So you do need to know these for your quiz Friday. All right, residual plots basically show you, it's just a visual representation of how far it is away from 0. So when you put coordinates, you always have an x and a y value, right? So your x's should be the same from your data table. So it was 0, 10, 20. But when it's a residual plot, your y will be the residual for that x. Does that make sense? So what was the residual when x was 0? Would be on the page.
0.2.
0.2. What was it when x was 10? And when x was 20. So now you're going to plot these coordinates onto this plot. So let's see if we can remember how to plot points. You'd be surprised how many other classmen still don't know how to do that. So let's practice that. I'll freeze it. Plotting your dot. All right, so plotting your dots. Everyone have 3 dots? So compare your dots to my dots. That's where they should be. So it's also about knowing how to read the graph. So here's the 0 on the x, here's my x-axis. Goes up 0.2. Here's the 10 on my x-axis, goes down negative 0.2. And then for the 20, it's on the x-axis itself. All right, we said that this was a good line of best fit because the residuals were close to 0. How can you tell visually that it's a good line of best fit? What are all of these close to? What's that line called? Not that it's close to the origin. Okay, the x-axis. So the closer, yeah, origin is like right in the middle, that wouldn't necessarily be the. It is close to the origin. But what we're looking for is the closer the points are to the x-axis. So I would write this down. So the closer the points are to the x-axis, the better the line of fit. And that's only referring to residual plots. So it'll tell me, given this residual plot, is this a good line of best fit, yes or no?
Yeah.
So yes, because they're all pretty close. If it was not, then they'd be farther away, and I've seen it be as far as like 7, 10, -20, right? So some of them can be drastically different, but the closer it is to the x-axis, the better. So good on there? All right, so that's all we're doing on that note sheet. Now we're gonna look at the correlation causation session. Can we do that? Okay, we've talked about correlation before. What's another word for correlation? Connected. How alike the variables are. There's like other words that are probably better. Like on your practice yesterday, they use the word association between the variables, the relationship between the variables. So correlation we talked about before. Causation, not yet, but what's the prefix of that word? Cause. So causation is where it directly causes something else. So that's actually what this first blank is right here. Able to use that word. So causation is that a change in one variable results directly from changing the other variable. In that case, it's reasonable to expect the data to show a correlation, a relationship between the two variables. So if there's causation, there's almost always correlation. But the reverse is not true. Observing a correlation, so like a trend within your data, does not necessarily mean that the change to one variable caused a change in another. So sometimes there is both correlation and causation. Sometimes it's just correlation, or sometimes neither. So here's another little table to kind of summarize that. Correlation is how like linear something is, measured between -1 and +1. So -1, by the way, is what type of correlation? Strong or weak? Strong negative. And then a +1 is strong or weak? Also strong. But then it's strong positive. All right, causation has to be demonstratable cause and effect. So can be measured by controlled study. And it shouldn't be assumed even when correlation is strong and predictable. So if you're erring on the side of caution, there's very rarely causation. Doesn't mean that there never is, but very rarely is it even that this causes this and nothing else. So here's an example, because we'll take you that. All right, in the summer, we tend to see an increase in ice cream sales, right? And an increase in sunburn. So if I compare the two, would we expect it to be a positive or negative correlation? Positive, so does one increases, so does the other. Now, does that mean that there's causation between sunburns and ice cream sales? Do sunburns cause you to want to buy ice cream? Could there be other reasons that you want to buy ice cream? Okay, do ice cream sales cause sunburns?
Wait, what?
So does eating ice cream or buying ice cream give you a sunburn?
No.
So there's definitely no causation between the two. So that's why between ice cream sales and sunburns, there's a correlation. No causation. Now, this says causation here, but I would argue that it's actually just a correlation. Because do you still sometimes want ice cream in the winter?
Yes.
So then there's, I wouldn't say that the sun is the only thing that causes you to want ice cream. So I would say there's just a correlation there. But is there anything else that causes sunburns other than the sun?
No.
No, and it's proven. They did scientific studies that the sun causes sunburn, not something else. So between these two, there is causation, because that's proven. There's only the sun that causes sun. Make sense? Okay. So then I don't think we need to fill out this first example because we just talked about ice cream sales and sunburns. But that's basically the gist of it. So let's do this one together. On the back side of that page. So a good test question would be to give you kind of a long word problem and say, is it correlation, causation, neither, or both? All right, so a group of biologists is studying the population of wolves and the population of deer in a particular region. Table 6. Oh, we don't have 6. Table 7. What are one of the variables? So we're looking here. A group of biologists is studying the population of wolves and the population of deer in a particular region. One of the variables is what? One of the things we're comparing. So wolf population. And then table 8, what's the other thing we're comparing? Deer population. All right, the biologists compared the populations each month for 2 years. After analyzing the data, the biologists found that as the population of wolves increases, the population of deer decreases. Why do you think that is? The wolves eat the deer. The wolves eat the deer. Okay, so we know that deer are a prey of wolves. So in that case, it is likely that an increase in blank causes a decrease in blank. So what's the first blank? Table 1. Wolves causes a decrease in what class? Deer. Right, not the other way around. It's not like an increase in deer causes a decrease in wolves. So then it is doubtful that a decrease in blank causes an increase in what? A decrease in what? Causes an increase in wolves. So it's not like the wolves leave and the deer leaves and the wolves tend to thrive. All right, that's not likely. Even though there is a strong, would you say this is a positive or negative correlation? Okay. Well, if one is increasing and the other is decreasing, then it should be negative. So the graph probably looks like this. So as the wolves increase, the deer decreases. So it's probably something like this is what it looks like. This does not imply what? So let me ask you, is there a correlation between the two? Yeah, we just said there's a strong negative correlation. Is there causation? Well, are there other reasons that the deer population might have decreased? Like what? Other predators, extinction, what else?
Lots of food.
Loss of foods, yes, hunting. So it's not just the wolves that could have contributed to that. So in that case, this does not imply causation. Causation is very hard to prove. Questions on that? Okay, so then you guys try the one that's underneath it, try filling in the blanks. So educational researchers are investigating the relationship between the number of musical instruments a student plays and the student's grade in math. So try filling in those blanks about correlation and causation. Researchers conducted a survey asking 110 students the number of musical instruments they play and what their grading is math. What's one of the variables, table 3? What's one of the variables being compared? Number of musical instruments. And then what's the other one, table 2? Grade in math. Could these blanks be reversed? Yeah, we're just listing the variables. Okay, simmer down. All right, table 4, you'll be next. But we have the researchers found that students who play a greater number of musical instruments tend to have a greater average grade in math. Is it likely that blank causes an increase in blank? So what would go in the first blank? It is likely that the number of musical instruments played, a lot, causes an increase in what class? All right, so anyone think it should be the other way around, that the math grade causes you to play more instruments? How many of you, and you don't have to put your business out there if you don't want, but raise your hand if you have a high grade in math but don't play any instruments at all. Okay, raise your hand if you have a good grade in math and you play at least one musical instrument. Like a few. Okay, so there was a lot less in that one. So it's doubtful that math grade causes an increase in instruments played. All right, so given that my dependent variable is probably the math grade. So it should go on the Y versus the instruments played. So would you expect this to be positive or negative? Because that's what their research said, and a lot of research actually does say that, by the way. But we know there are some outliers, so. Even though there is a strong, you guys said it, positive correlation between the number of instruments played and math grade, does this imply causation? So there's definitely a correlation. Is there a causation? So this does not imply causation. Because there may be other reasons that what? There may be other reasons that their math grade is higher. Like what? Work ethic, studying, paying attention, having good effort. So it's not just that you have to play an instrument to be good at it. All right, questions, comments, concerns? All right, so then you do have a paper practice to work on. I do want to tell you guys this though. I won't tell my other classes, but I won't be here. No. I know you're not really that.
So sad. No, Miss Medina.
You guys still have to do always. And here's like a preview of that. So even if you decide to do nothing, you're still responsible for getting this done. One of them is a practice quiz. So this would have been the study guide for the unit test, except for now I'm calling it a quiz. And I'm not making it 100 class points. I'll make it the same as the quiz. I'll make it 50 points. But it looks exactly like your quiz. So if you can do everything on there, or if you don't and you ask questions, whether by email or something, look it up. Yes, it is.
So it seems that the
It should be faster. So that's your first priority, and it says, that might take you the whole class time, that's fine, that's your first priority. This will be like extra credit almost. Cause you can play this Kahoot and then get more prep in for your quiz, that'll be on Friday. So questions on that? Okay, so then work on your practice, just like the other two. The keys are over here, fully filled out, but you cannot like just straight up copy it. Like if you do, right, you get 10 homework points. That doesn't do a whole lot for your grade. So, no. It's